Hi, and welcome to today's calculation exercise on efficient portfolios. Before watching this calculation exercise, I suggest that you watch the first 3 portfolio theory videos. You might also benefit from watching the 4th and doing a few questions on this area. Now, please pause the video to look through the question and then proceed when you're finished.
Alright, hi and welcome, I'm Johan, and today we're gonna work with a concept called efficient frontier. So what we're going to do is we're going to try to assess if it's good or bad to invest more in Holmen, or if it's good or bad to invest more in Volvo, and we want to be absolutely certain that it's good or bad for every possible investor. So we're going to use this formula here, which gives you the optimal, the weight that gives the minimum variance of a portfolio of 2 assets. So when you have an asset like with Holmen and Volvo, you have different kind of weights. One of these combinations will yield the least variance of the portfolio. And this formula here magically gives you that. So if I plug everything in, I will get the weight of asset 1 that will then give me the perfect, the minimum variance of these possible combinations. I've written the information we were given, so the standard deviation of Holmen of Volvo, the correlation between the two, and the weight we currently have in Holmen, and then I took 1 minus this to get the remainder in Volvo. So I have 79.7% in Holmen. That means I have 20.3% in Volvo. As you can see, here there are 1s and 2s, and I've written H and V here. So H stands for Holmen, V for Volvo. You could, of course, also call Holmen the first company, or the first asset, and Volvo the second one, and then this number should go into where the 1 is. That doesn't really matter, it's just an indexation. But we're going to start looking at the combination of different portfolios in this graph here. So we knew that the expected return of Holmen was 12%, and the expected return of Volvo was 14%. Okay? So Volvo has a higher expected return than Holmen, and also Volvo is more risky than Holmen. So that means we can draw 2 points. For example, we can have maybe Holmen here. So this is Holmen. And we can have Volvo maybe here. So further to the right means more risky. That's why we have the standard deviation on this axis. And further up means higher return. So Volvo has both higher risk and higher return. And as you remember from the videos with Iñaki, if you have perfect correlation between 2 assets, then in this graph, the combination would be a straight line between the 2. So this here means if you invest 100% in Holmen and nothing in Volvo, you would get the risk and return of Holmen, of course. If you invest 50% in each, you would end up somewhere in between. So you get an average of their risk and you get an average of the return. If you invest 100% in Volvo, you would end up here. So this is 100% Holmen, 90% Holmen, 80, 70, and so on until you have everything in Volvo. If you had perfect negative correlation, so correlation of -1, then you will get a picture looking something like this. So it would still be straight lines, but in this case they would bounce towards the y-axis. And if you have anything in between, so you don't have perfect correlation or perfect negative correlation, it's going to look more like this. All right? So in our case, we have correlation of 0.48. Maybe this is the picture. It doesn't have to be exact. That's not relevant for us. But it will be some kind of arc here. Okay, so why is this important? Well, what we usually want is we want to have a higher return and a lower risk. Both of those are good. So in case we can get a higher return to the same risk, that's good. If we can get a lower risk to the same return, that is also good. And here we can compare and already say that some of these combinations are bad. Okay, so for example, investing 100% in Holmen must be bad. Why? Well, I can get another investment here, which has exactly the same risk as Holmen, but has a higher return since it is above. I could also compare Holmen to, for example, this point, where I have a lower risk and a higher return because I'm going up and further to the left. So this point here must be better than investing in Holmen. And in fact, as we keep moving up, we can say that the point that is here, that is the furthest to the left of all, it's called the minimum variance portfolio or minimum risk portfolio, that is a cutoff point. Okay, so what do I mean by that? Well, everything that is below this minimum variance, so for example, investing in Holmen or anywhere else here, investing 100% in Holmen or fairly small amounts in Volvo, all of these points have a lower return, they are further down, and they have a higher risk. Higher is almost implied because this is the minimum risk, so everything else has a higher risk, but the ones below also has a lower return, so they are bad in both aspects. So if we can find this minimum variance portfolio, it means that investing more in Holmen is obviously bad. So why is it Holmen that is obviously bad? Well, that's because Holmen has a lower expected return than Volvo. So the only reason to invest more in Holmen would be to get a lower risk. And if there's another place with higher return and lower risk than Holmen, there's no point in investing more in Holmen. Investing more in Volvo, on the other hand, that might be good, depending on the investor. So if I do invest more in Volvo, I go maybe here, I get a higher expected return, but I also take a higher risk. So then it depends on your risk preference. If you're willing to take more risk to get a higher return, yes, then it's good for you to invest more in Volvo. But that does not have to apply to everyone. Myself, for example, I'm very risk averse, so I would prefer to take the least risk possible of these combinations. Even if I get more return by taking more risk, I'm not willing to make that trade. I want the lowest risk. So going further into Volvo might be good or it might be bad, depending on who you are. Okay, so how can we then find this point? What weight of Holmen and Volvo would give us this minimum variance point? Well, we have the formula here. So this formula will tell us exactly how much we need to invest in Holmen to reach this minimum variance point. So all we have to do is to plug the numbers that we are given into this formula. Okay, so we start by taking the variance of Holmen, which was 0.25 to the power of 2, minus the standard deviation of Holmen, 0.25, times the correlation, 0.48, times the standard deviation of Volvo, which is 0.35. Then we divide it by the variance of Holmen, minus 2 times the standard deviation of Holmen, times the correlation, 0.48, times the standard deviation of Volvo, which was 0.35. And then we add the variance of Volvo, 0.35 squared. Okay, and if we plug this in to our calculators, this whole thing, so remember you need a bracket on the top and a bracket in the bottom. If we do plug this in, we will find that to get the minimum variance, you should have 0.797027 in Holmen and the rest in Volvo. And like a coincidence, this happens to be the current weight in our portfolio. So right now, we have the minimum variance portfolio. And what did that imply then? Well, we said that we should not invest more in the stock that has the lower return. Since Holmen is the one with the lower return, there's absolutely no reason to invest more in Holmen. Take a larger weight in Holmen would get both a higher risk and a lower return, so it's bad in both aspects, and therefore it's not good for any rational investor. It's not obviously good to increase our weight in Volvo, because we would get a higher return, but we would have to pay by getting a higher risk as well. So it's might not be good for all investors. Some might, like me, might prefer the lowest risk. So the only of the alternatives that we were given that were correct is alternative C. It is without a doubt a bad decision to invest more in Holmen. All right. One more thing that I forgot to mention. This upper part is called the efficient frontier of this combination. It's efficient because you cannot tell which of these investments are better for any particular investor, whereas this lower part then is inefficient. It's an inefficient choice to take a portfolio with lower return and higher risk than some other portfolio. All right, that's it for today. Thank you very much.